us proceed to thermal deformation. Okay? So you can take this as parang type of axial deformation. Okay? Mapapansin nyo sa mga previous problems natin na sinolve kanina, yung nagpapastress sa member natin is due to the applied load dun sa structure. Tama? Ngayon, yung nagpapa-stress naman dito sa member natin is the change in the temperature. Okay? So when the temperature changes, our member or in general, the body reacts. Okay? So magde-deform siya. Okay? Knowing, no, if mag-i-increase yung temperature or pag umiinit, anong mangyayari sa member natin? The member will, yes, expand. Tama? Pero pag bumaba naman yung temperature or lumamig, edi, yung ating member will contract. Okay? Or it will shrink. Tama po ba? So ito yung mga basic concept natin dito. Okay? And may isa lang formula na nadagdag dito. Okay? And that is the thermal deformation of formula given by this alpha L delta T, or kung basahin ng marami, that is alat. Tama? Para madali siyang isaulo. Where your alpha, that is the linear coefficient of thermal deformation. Okay, and by the way, itong delta T natin, that is the change in the member due to thermal change. That is the change in the length of the member due to temperature change. Okay? L is the original length of the member and delta T is the change in the temperature. Okay, so yan lang yung nadagdag natin dito, no? And everything else, the same yung gagawin natin. Okay, so let us proceed to the sample problem.
A composite bar is comprised of brass and copper rod as shown. A load P, 25 kN, is applied at 25 degrees Celsius. Find the stresses in the materials when the temperature rises to 50 degrees Celsius. For copper, we have the modulus of elasticity 120 gigapascal and coefficient of linear thermal expansion is given. For the brass also, modulus of elasticity is 90. Then alpha is 20 times 10 raised to negative 6 per degree Celsius. So for the first condition, if the supports are unyielding, ibig sabihin, hindi po gumagalaw yung supports natin dito sa point A and point C. Okay, so kunin muna natin yung areas, cross-sectional area of the brass and the copper rod. For the brass, that is pi over 4 times 40 squared. Store nyo tong value na to kay E. For the copper naman, that is pi over 4 times 25 squared. Store nyo naman to kay F. Right? So, since we have here thermal change, so kunin natin yung thermal deformation ng bawat material. So, thermal deformation is alpha L times delta T or alat. Okay? The brass, that is alpha ng brass is 20 times 10 raised to negative 6. Length of the brass rod is 800. The change in temperature, sabi sa problem, no, yung initial natin na temperature is 25 degrees Celsius. And then, nag-increase yung temperature natin to 50 degrees Celsius. So, bale, yung 50 degrees Celsius natin yung final temperature. Tama? Kung by sana to, yung word na 2, naging by, edi yung 50 degrees Celsius na yung delta T. Pero 2 man, so yung 50 degrees Celsius yung final temperature. So this would be final temperature 50 minus the initial na 25. So this would be 0.40 millimeters. For the copper rod, deformation due to temperature, delta Tc, that would be alpha of the copper is 18 times 10 raised to negative 6. Length of the copper rod is 1000. Change in the temperature is final minus initial. This is 0.45 millimeters. Now, calculating the deformation due to temperature change, that would be 0.40 plus 0.45. Total is 0.85 millimeters. Ngayon, saan natin i-reflect tong total na to dito sa figure natin? So, gagawin natin is, let us imagine no, na mag-e-expand yung one side of our structure. So, pwedeng mag-expand is itong left side, pwede din dito sa right side. So, gagawin mo, pili ka lang ng isa. Okay? So, say, dito lang tayo mag-expand sa right side. Okay? So, para mag-expand to, imagine natin no, na matatanggal itong fixed support sa point C. Tama? Imagine lang. No? So, if wala na to, kung wala na yan, di mangyayari, pwede nang mag-expand yung rod natin dito. Tama? So, yung makikita mo ditong total na expansion is yung delta T total. Tama? Due to the temperature change. So, our structure is expanding kasi yung nakuha nating value dito is a positive value. Kasi nag-increase man yung temperature. So, ibig sabihin humahaba yung ating material. Tama? Mangyayari is since meron naman talagang fixed support dito, no, yung actual na nangyayari is wala talagang deformation na nangyayari dito. Kasi pinipigilan ng support na to yung mangyayaring deformation due to temperature change. So, bale, yung deformation na to will be resisted by the axial deformation. Okay, that is contributed by both the brass rod and the copper rod. So, kumbaga may reaction ka dito, may axial force ka dito, tawagin natin yang R sub R, reaction sa right, na yan yung magpapabalik sa deformation na to its rightful place. Kasi fixed naman talaga to. Tama? So, pwedeng by deformation equation, pwede natin magamit simultaneously si deformation equation and si equilibrium equation dito sa part na to. Paano ba? Tingnan muna natin dito sa deformation. Sabi natin, di ba, na due to temperature change, we have a total deformation that is delta T. And this delta T will be resisted by the axial deformation delta R. Itong delta T na to, nakuha na natin yan as 0.85 millimeters. Okay? So, yung axial deformation na to is contributed again by both the brass rod and the copper rod. Okay, so this 0.85 is equals the axial deformation PL over AE of the brass rod plus the PL over AE of the copper rod. Now, ano ba yung PB and PC natin? Well, walang problema si length, si area, and si E, yung mga properties ng materials natin kasi bigay. Dito yung unknown is yung force ng brass and force ng copper. So, paano natin makukuha si PB and si PC? So, dyan na papasok si equilibrium equation. Paano ba natin yan titingnan? Kunin muna natin si force of the brass rod. So, paano ba makikita yung force ni brass rod? If ikakat natin yung mismong material na yon. Say, dito natin ikat. And let us consider the right cut member. Now, here is your cut member. Since yung inassume natin dito na axial deformation ng ating brass and copper rod are compressive, diba? Kasi yung force na to is nagpapakompress pabalik ng ating material. Tama? So, yung force mo dito for the copper rod should be compressive force. This is PC. Na-imagine nyo ba kung bakit siya naging compressive? Kasi if titingnan mo, no, yung thermal deformation natin na 0.85 is parang hinihila niya yung ating material. So, parang natitense. Tama? So, yung resistance, yung axial resistance is opposite. Pinapa-compress niya naman yung material natin para hindi talaga siya mag-move. Kasi fixed naman talaga dito. So, here, this is tensile. This one naman is compressive. Okay? Kaya yung force again of our brass is compressive. By the way, PB pala to, no? Sorry. Right? So, by summation forces horizontal, pwede nating sabihin that PB here is equals the reaction at the right support minus 25 kilonewton. So, gawin natin tong naka-newton, 25,000. Okay? So, meron na tayong force kay PB. Kunin naman natin yung force kay copper. So, if gusto nating tingnan yung reaction ng copper, i-cut natin dun sa copper banda din. Consider ulit natin yung right cut member. We have this cut part. We have again our right reaction, and then yung copper natin is compressive ulit. Tama? Kasi compressive yung deformation na in-assume natin dito. So, this is P sub C. No? So, hindi nakasali si 25 kilonewton kasi nasa junction yan ng brass and copper. So, si PC and RR lang yung andito. From our cut na member, we can say that the reaction of the copper is just equals the reaction at the right support. Tama? So, pwede mo na yung isubstitute dito. You have here 0.85 equals force ni PB is this one, RR minus 25,000. Length is, ilan ba yung length ng ating brass rod? 800. Area of the brass rod nakastore kay E. Modulus of elasticity is 90,000. Plus, force ng copper is just the RR. Tama? Length is 1,000. Area of the copper nakastore kay F times 120,000. O, diba? Nagamit natin simultaneously si deformation equation and sulat pala natin dito, no? Si equilibrium equation. Tama? From here, you can get the value of the reaction at the right support. And ilan ba yung lumalabas dyan? This is 42,695.859 Newton. And from here, you can get the value of PB and PC. Force ng brass and force ng concrete mula dito sa equilibrium equation natin. I-calculate nyo nga ilan ba yung PB natin dito. X minus 25,000, that is 17,695.859. Tama? Newton. Si PC naman is just equals RR, so this one is yung 42,695.859 na. So we have our reactions sa brass and copper rod natin, so we can eventually get the stresses dun sa mga materials na yon. Unahin natin dito sa brass rod natin. That is force of brass rod over the area of the brass rod. That is 14.08 megapascal. For the copper rod naman, this is force of the copper over the area of the copper rod. This is 86.98 megapascal. Okay? So, these are the answers for number 7. Take note pala na nag-positive yung nakuha nating forces sa brass and sa copper rod. Ibig sabihin, tama yung assumption natin na compressive force yung i-react ng copper and ng brass rod natin. Okay? Otherwise, if negative yan, ibig sabihin, tension lang. Okay? Pero same pa rin na value or yung magnitude na nasagot. Okay? Nagkaiba lang sa assumption. For number 8, if the left support yields by 0.1 millimeters. So if we're going to calculate the thermal deformation, same pa rin, di ba? The thermal deformation sa brass is still 0.40 millimeters kasi wala mang nag-iba sa properties ng brass natin and sa initial and final temperature, yun pa rin. Sa copper din, same, 0.45. We're going to calculate the total thermal deformation, that is still 0.85 millimeters. Okay, so i-project natin yan dito. Since yung left support man yung mag-yield ng 0.1 millimeters, gagawin natin. Yung left support din, yung ipapa-freely move natin. Freely deform. Okay, so again, imagine natin na matatanggalan ng support dito sa point A. So, bale, yung rod natin dito will deform up to this length. So, say this would be our 0.85 millimeters, the total thermal deformation. Pero, sabi nga sa problem na pwede yang mag-yield ng 0.1 millimeters. So, mula dito sa point na to, pwedeng mag-move yung ating left support up to 0.1 mm. Tama? So, bale, yung lalabanan lang pala ng support natin na deformation is up to this length lang. Tama? 0.85 minus 0.1, which is 0.75 millimeters. Okay? So, the same, no? Parang hinihila pa rin yung ating material dito. So, yung ibibigay ng ating rod, ng ating brass and copper rod are compressive force. So, may reaction tayo dito, no? Yung ire-react na force due to this thermal change, tawagin natin tong R sub L kasi nasa left. Yung 0.75, this one, yan lang yung lalabanan ng axial deformation natin contributed by both the brass rod and the copper rod. Okay, bali nabawasan lang. No, kasi pwede mang mag-move yung left support natin. So this is based on our deformation equation. Let us get the value of force PB and force PC using the equilibrium equation. So for the brass rod, cut lang natin para ma-expose yung force na nire-resist ng brass rod. Consider natin this time yung left cut member. We have here the reaction at the left support. Okay? So dito, 'di ba? Sabi natin that itong 0.75 is parang patens, hinihila yung ating member. So yung reaction ng ating brass and copper would be the opposite, which is compressive. Okay? So yung force natin dito would be compressive force for the brass rod. So here we can say that the force of the brass rod is just equals the reaction at the left support. Kunin naman natin yung force ng copper rod natin. I-cut lang natin dito sa copper banda and consider ulit natin yung left cut member. We have here our reaction at the left support. Take note na meron kang axial force dito sa junction which is 25 kilonewton. And then, yun na nga, inassume natin na compressive yung ibibigay na force ni copper, yung ilalaban niya. So, this is PC. From here, you can say that force of the copper is equals the reaction at the left support plus 25,000 Newton. So, you can substitute this equation dito sa deformation equation natin. PB mo is yung reaction sa left. Length is 800. Area of the brass rod nakastore kay E. Elasticity is 90,000. Force of the copper rod is reaction at the left support plus 25,000. Length is 1,000 millimeters. Area is nakastore kay F. Modulus of elasticity is 120,000. As you can see, again, na-utilize natin both the equilibrium equation and deformation relationship. So we have here, we can solve the value of the reaction at the left support. The reaction at the left support is 13,537.868. Tama? This is in Newton. Okay, from here you can get the value of the force ng brass rod and the force dun sa copper rod. So si brass rod, that is just equals RL, so this is also 13,537.868. And then the force of the copper rod, add lang natin si 25,000. This is 38,537.868 Newton. Okay? So these are your forces sa brass and copper rod. We can now solve the corresponding stresses, which is axial stress, force over the area. Stress sa ating brass rod, that is 10.77 megapascal. And sa ating copper rod is force of the copper rod over the area of the copper rod. This is 78.51 megapascal. These are the answers for number 8. Yung nakuha nating forces sa brass rod and copper rod are positive. Tama? So, ibig sabihin, compressive force din yung nire-react ng brass and copper rod sa situation na to. And then, nag-positive din yung reaction sa left support. Ibig sabihin, tama yung direction of our force. So, as you can see, yung nakuha nating stresses sa number 8 is mas maliit, diba? As compared sa stresses na nakalculate natin sa number 7. Kasi, konti lang yung deformation na nilalabanan nila. A rigid bar, as shown in the figure, is pinned at B and attached to two vertical rods, steel and aluminum rod. The bar and the vertical rods are initially stress-free. Determine the stress in the aluminum rod if the temperature of the steel rod is decreased by 30 degrees Celsius. Neglect the weight of the bar. So, when the bar is initially stress-free, so ito po yung figure na yan. Bali level yung rigid bar ABC. Okay? Pero nung nag-decrease na yung ating temperature by 30 degrees, may nangyayari na po dito sa ating structure. So, utilizing our two equations, we have the equilibrium equation and compatibility equation. Unahin natin dito si equilibrium equation. So, we can take or we can use the moment equation. We can take moment at the pin, point B. Tama? Equate natin yan to 0 to maintain equilibrium. Alright? So, to expose the forces na ine-exert ng steel and aluminum when the temperature changes, simple, i-cut lang natin yung steel rod and aluminum rod natin. Thereby, exposing the tension dun sa ating steel rod and sa ating aluminum rod. Tawagin natin yung force natin dito sa steel rod as PST, dito naman sa aluminum rod as PAL. Okay? Taking moment at point P, assuming counterclockwise is a positive rotation. Okay, the force due to the aluminum rod, that is counterclockwise, so that is positive. Moment arm is 1, so that is 1 times force of the aluminum. The moment due to the force ng steel is creating clockwise rotation, so that is minus. Moment arm is 0.50, so that is 0.50 times force ng steel. Sila lang naman dalawa, diba, yung nagke-create ng moment with respect to B. So, equate na natin yan to 0. Tama? This would be our equation 1. As you can see, we again have two unknowns. So, we need another equation. And we can go to our compatibility equation, which is through their deformation relationship. Let us calculate the deformation due to temperature change dito sa steel rod natin. Okay? That is delta Ts. Still, this is alpha L delta T of our steel rod. Okay? Alpha of our steel rod is 11.7 times 10 to negative 6. Length is 900 millimeters. Delta T is ito ng 30 degrees. That is because of the word by. Tama? Decreased by 30 degrees Celsius. So, ibig sabihin, that is already the change in the temperature. Delta T. So, ilan ba yan? Take note na sinabi sa problem, decreased by. So, ibig sabihin, nag-cool down yung temperature dun sa steel natin. Tama? Yung delta T natin is a negative value kasi decreased by man. Okay, so yung magiging value ng ating thermal deformation dito is also a negative value. And that is negative 0.3159 millimeters. Ano bang ibig sabihin pag negative? Tama, nag-shrink or nag-shorten yung member natin. So, with that, no, yung steel pala natin is nag-shorten. So, from this original length, let's say hanggang dito na lang yung naging steel rod mo. due to the change in the temperature. So with the change in the length of the steel rod, edi mangyayari yung ating rigid bar ABC is hindi na siya level. Tama? Ito na yung nangyari sa ating rigid bar ABC. Of course, this will remain straight kasi sabi man sa problem, rigid. So bale, if nag-shorten yung ating steel rod, edi yung aluminum rod natin is nag-lengthen. Tama? Humaba siya up to this length right here. Tawagin natin tong delta AL. Okay? Yung pag-lengthen ng ating aluminum rod is what we call axial deformation. So this deformation, pwede mo yung masolve as PL over AE. Kasi if titingnan mo yung aluminum rod mo dito, no? Bale, nahila to. Tama? Axial yan kasi again, your force is perpendicular to the resisting area. Tama po ba? Ngayon, ano yung magiging length na to? Tawagin natin tong delta sub A. Yung displacement ng point A mula dito sa initial point niya patungo dito sa point na to. Ma'am, hindi ba yan yung deformation due to the temperature change dun sa steel rod na 0.3159? By the way, nakalimutan ko, yung kinuha ko lang dito na thermal deformation is yung sa steel lang. Kasi sabi sa problem, no, the temperature of the steel rod is decreased by 30 degrees Celsius. So, hindi kasali yung aluminum rod. I don't know kung paano yan nangyari na yung steel lang yung nag-change ng temperature. Basta yan yung condition sa problem na to. Balik tayo dito. Yung delta A na to, displacement ng initial point of A, ng initial position ng point A patungo dito sa point na to. Bakit yan hindi equal sa deformation due to the temperature change dito sa steel? Kasi titingnan mo, if ito yung ating initial position ng rod, no? Rod ABC. And then ito yung original length of our steel rod. So due to the temperature change, no? Sabi natin, nag-shorten na yung ating steel rod. So itong thermal deformation, ito na yung nakalculate natin na delta TS. Tama? Pero hindi pa ito yung displacement ng A mula dito patungo sa final position niya. Kasi bakit? Habang kino-compress kasi yung ating steel rod, may nilalaban siyang potential na reaction. Tama? Kaya kumbaga, meron ka ditong tensile deformation. Nahihila yung steel rod mo din. Okay? And this axial deformation, specifically tensile deformation, this is tawagin nating delta ST, which is ito yung PL over AE ng steel natin. Tama? Kaya yung nangyayari, yung magiging final position ng point A natin is hanggang dito na. Tama? Nabawasan dahil sa resistance din ng steel rod natin. Kumbaga, this will be our delta A. So, para pala kunin yung delta A natin, we have to consider the axial resistance din ng steel rod natin. With this, pwede nating ma-express yung displacement ng point A sa thermal deformation and sa axial deformation ng steel, which is delta TS minus the axial resistance of the steel rod. Tama? So, delta A mo, this is, yung nakuha mo dito, diba, is negative. Pero, yung ginawa mo is, project mo naman dito sa drawing mo na nag-shorten siya. Tama? So, you can use the positive sign. Kasi in-indicate mo naman yung direction ng deformation dito. So, deduct natin sa axial deformation ng ating steel rod, axial resistance, which is PL over AE of the steel rod. So, ano pa ba? Pwede mo ding ma-relate yung delta A mo dito sa deformation, axial deformation of the aluminum rod using ratio and proportion. So, by ratio and proportion, pwede mong sabihin delta A over 0.50 equals delta, the axial deformation of the aluminum over 1. Okay? Take note na axial deformation lang to kasi again, hindi po kasali si aluminum rod sa nag-change ng temperature. Okay, so yung reaction lang niya is axial deformation. Right? So yung deformation pala delta A is kalahati sa axial deformation sa aluminum. So this is kalahati ng PL over AE of the aluminum rod. Tama? So gawin natin, itong L over AE na to of the steel, store nyo to kay A. And then, ito naman, si 0.5 times the length over AE, store mo naman to kay B. Okay, so bali yung matitira dito is yung nakastore kay B times the force. Okay? Now, to generate our second equation, equate lang natin delta A equals delta A. So we have 0.3159 minus yung nakastore kay A times PST. Andito po ako sa equation na to. Equate natin sa delta A, which is this value, yung nakastore kay B times P aluminum. Tama? As you can see, you now have your second equation. Now, rewriting our equations, we have equation 1, that would be PAL minus 0.50 PST equals 0. This is from equilibrium equation. Second equation from our compatibility equation, i-rewrite natin po to. So, unahin natin si P aluminum. So, that would be yung nakastore kay B times P aluminum. Okay, ibalibag natin dito si force ng steel. So, that would become positive. Yung nakastore kay A times PST. And then on the other side would be the constant, 0.3159. Okay, so from here you can get the values of aluminum and steel. Ilan ba yan? Unahin natin si aluminum, 10,166.90. For the steel naman, that is 20,333.79. These are all in Newton. Pero yung tinatanong is the stress ng aluminum. So, napakadali kasi axial stress lang naman. Tama? So, that is force of the aluminum over the area of the aluminum. Force of the aluminum, 10,166. Area of the aluminum is given 1,000 square millimeters. So, this is 10.17 megapascal. This is already the answer for number 9. Pero pag tinanong din yung stress ng ating steel rod, madali din. That is force of the steel rod over the area of the steel rod. Area of the steel rod is, by the way, 400 square millimeters. Solving this, you can get 50.83 megapascal. This is the answer. Ay, hindi pala to sagot. In case lang na tinanong.